Welcome all of you dear friends. This is the simplest and easiest way of teaching learning process in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra, now serving as a principal in Lokanete Dr. Balasaheb Vikhe Patil, Padma Bhushan awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalay and Junior College, Dad Budruk Taluka Rahata. As long as our 11th Science Oscillation chapter is concerned, this is the lecture number 11, and in this lecture we want to discuss about period of a simple pendulum. So, before learning directly, you should know what is meant by period. Period means time required to complete one oscillation. We call it as period. Okay. Then now we have to derive the formula of period of a simple pendulum. But before that, we will have to discuss about first question, definition of ideal simple pendulum and practical simple pendulum. What is ideal simple pendulum? Ideal simple pendulum is a heavy particle like this. Heavy particle. Particle should be heavy. This is a heavy particle, and this particle is suspended by means of massless, inextensible and flexible string. We call it as ideal simple pendulum. What is practical simple pendulum? Practical simple pendulum is a heavy dense sphere suspended by means of light weighted string and inextensible string. Here the flexible word is deleted as long as the definition of practical simple pendulum is concerned, because defining the practical simple pendulum, string is either flexible or rigid. If the string is like this, then this also follows practical simple pendulum. This is a rigid string. What is flexible string? Flexible string is like this. This is a flexible string. This is flexible. So, string is either flexible or rigid, whatever it may be. So, the flexible word is deleted while defining the practical simple pendulum. Ideal simple pendulum, we will have to mention three properties of string, and the particle is heavy. So, ideal simple pendulum is a heavy particle suspended by means of massless, inextensible and flexible string, while practical simple pendulum is a heavy sphere, heavy and dense sphere. Sphere should be dense like this. Sphere should be dense. This sphere should be dense. Heavy and dense sphere suspended by means of light weighted. It should have some weight, but that weight should be light, and inextensible string. It should be flexible or rigid, whatever it may be, and so that the flexible word is deleted while defining the practical simple pendulum. Okay, we want to derive period of a simple pendulum. So, let us see a diagram. This diagram consists of this theta is an angular displacement. This capital L is length of the pendulum from center of gravity up to point of suspension of rigid support. This T dash is a tension. T dash is a tension acting on the string. Mg is acting vertically downward, and this Mg is called as weight of the bob. Weight of the bob is exactly acting vertically downward. This Mg is split up into two components. One component is mg cos theta here, and another component is mg sin theta, which is directed towards the mean position, and so that this mg sin theta is acting as a role of restoring force, dear student, because this mg sin theta try to restore the pendulum to its original condition. And so that we can write the first equation, that is F is equal to minus mg sin theta. F is equal to minus mg sin theta. This negative sign indicates that what? Negative sign indicates that angular displacement is from mean to extreme, while restoring force is directed towards mean. So restoring force and angular displacement are oppositely directed. That is the meaning of negative sign. That also I have written here. Negative sign indicates that restoring force F and angular displacement theta are oppositely directed. As theta is very small, that is theta is less than 10 degree, then sin theta is approximately equal to theta. We can write sin theta is approximately equal to theta if that theta should be less than 10 degree. And so that above equation becomes F is equal to minus mg here. F is equal to minus mg theta. But what is the value of theta? Theta is equal to this arc x upon L. X upon L, that is the value of theta. Put the value of theta here. So we get what? F is equal to minus mg x upon L. Here this small m, mass of the bob, g is acceleration due to gravity, capital L is length of the pendulum. These three factors are constant, and so that we can write restoring force is directly proportional to minus x, mg L are constant. And this is a definition of simple harmonic motion. For smaller displacement, when the displacement is smaller, then restoring force is directly proportional to displacement and is oppositely directed, because restoring force is directed towards mean position while displacement is directed away from the mean position. And from that equation it is clearly indicates that motion of the simple pendulum is simple harmonic in nature. Many times, as long as examination is concerned, the question asks, prove that motion of the pendulum is simple harmonic in nature. So we come up to this. So there may be a possibility of asking the question like this. Number 1, draw a neat labeled diagram to find period of a simple pendulum. So you should draw this diagram and labeling. Diagram and labeling, this question is of 2 marks. The second question is define ideal and practical simple pendulum. Definition of ideal simple pendulum, 1 mark. Definition of practical simple pendulum, 1 mark. And the third question is that show that simple pendulum performs simple harmonic motion. That I have already told. Come up to this. F is directly proportional to minus x. This indicates that motion of the simple pendulum is simple harmonic in nature. Okay, we will proceed further. Then we get here F is equal to minus mg x upon L. In magnitude form we can write magnitude form, neglecting negative sign. F is equal to mg x upon L. If we put the value of F by Newton's second law, what is the value of F? F is equal to ma. M means mass and A is acceleration. F is equal to ma. If we put F is equal to ma, then we get what? Ma is equal to mg x upon L. M get cancelled and you will get what? This x is divided by A. We get A upon x is equal to g upon L. What is A? A is acceleration. What is x? It is displacement. That is acceleration per unit displacement. Acceleration per unit displacement is equal to g upon capital L. And this is equation number 3. We come up to this. Then let us clean the board, but before cleaning, take a screenshot for your further study. Take a screenshot. Then we'll proceed further. We get acceleration per unit displacement is what? Acceleration per unit displacement we get A upon x is equal to g upon L. So what is the formula of period of SHM? While learning the chapter period of SHM, we know capital T, we know capital T is equal to 2 pi upon square root of acceleration per unit displacement. This is the formula of period. But acceleration per unit displacement we got is g upon L, we put here. So t is equal to 2 pi upon, what is acceleration per unit displacement, which is equal to g upon L. Take this on numerator, we will get what, t is equal to 2 pi square root of L upon g. This is the formula of period. So in this way, capital T is equal to 2 pi square root of L upon g. This is the formula of period, and that we want. That is our fourth question. Derive the formula of period of a simple pendulum. We will have to come up to this. Capital T is equal to 2 pi square root of L upon g. Then what is the last question? Question number 7. See here. Derive the formula of a frequency of a simple pendulum. Frequency is a reciprocal of period. So we can write frequency of a simple pendulum, f is equal to 1 upon capital T, which is equal to 1 upon 2 pi square root of g upon L. Take reciprocal, L upon g, g upon L. 2 pi, 1 upon 2 pi, T, 1 upon T. That is frequency of a simple pendulum during simple harmonic motion. And that is the required answer of question number 7. Then we want to study now question number 5 and question number 6. But before learning question 5 and 6, let us clean the board. Let us clean the board. We will clean the board. Take a screenshot, we will clean the board. Question number 5. What assumptions we made while determining the period of a simple pendulum? When we determine period of a simple pendulum, what precautions we take? What are our initial fundamental assumptions while determining the period of a simple pendulum? The first assumption is that length of the pendulum should be large. We will write here assumptions. We assume following things. Number 1, length of the pendulum should be large. Number 2, amplitude of oscillation should be small. That is, amplitude should be less than 10 degree. That is, amplitude should be 20 times less than length of the pendulum. What is the meaning of this? Amplitude should be 20 times less than that of length of the simple pendulum. Suppose, dear students, length of the simple pendulum is 100 centimeter, then 20 times less than 100 centimeter, that means amplitude should be only 5 centimeter. That is the correct answer. Amplitude should be only 5 centimeter for the length 100 centimeter. So amplitude should be 20 times lesser than that of length of the simple pendulum. These assumptions we made while determining the period of a simple pendulum. Number 3, oscillation should be in a particular single plane. Oscillation should be in particular single plane. That means oscillation should be like this. It should not like this. Oscillation up to the end of the practical, up to the end of the experiment, it is completely at a particular single vertical plane. Oscillation should be in a particular single vertical plane. Vertical. In a particular single vertical plane. So these are the assumptions we follow while determining the period of a simple pendulum. What assumptions are made while deriving the period of a simple pendulum, So that is the answer of this question. So these 3 points should come as long as your assumption is concerned. And then the last question that we want to discuss now is laws of simple pendulum. State laws of simple pendulum. Question number 6. Let us take a screenshot, then we will proceed further. Laws of simple pendulum. 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 Okay. We know period of a simple pendulum is 2 pi square root of L upon G. And according to obeying this equation, this formula, we can state easily the laws of simple pendulum. The first law is called as law of length. Law of length. While stating the law of length, we can write T is directly proportional to what here? T is directly proportional to root L. That is, period of a simple pendulum is directly proportional to square root of its length. Period of a simple pendulum. Period of a simple pendulum is directly proportional to the square root of its length. That is, T is directly proportional to root L. That is law of length. Number 2, law of acceleration due to gravity. Law of acceleration due to gravity. What is law of acceleration due to gravity? For that purpose, we should remember the formula. T is inversely proportional to root G. T is inversely proportional to root G. So what we write? Period of a simple pendulum. Period of a simple pendulum is inversely proportional to the square root of acceleration due to gravity. Acceleration due to period of a simple pendulum is inversely proportional to the square root of acceleration due to gravity. Number 3, law of mass. Law of mass. Here, mass of the pendulum small m. Mass of the pendulum small m is absent in the formula. No mass. So period of a simple pendulum does not depend upon mass of the pendulum. That is law of mass. Period of a simple pendulum. Period of a simple pendulum doesn't depend upon mass of the pendulum. Doesn't depend upon mass of the pendulum. That is law of mass. And last one, law of isochronous. Law of isochronous. Law of isochronous states that period of a simple pendulum does not depend upon amplitude of oscillation, provided that amplitude should be small. As long as the amplitude should be small, this law of isochronous will obey, otherwise not. If the amplitude is large, this law of isochronous disobey. So to obey the law of isochronous, most important precaution is that for a smaller amplitude, period of a simple pendulum does not depend upon amplitude of oscillation. Okay, we can write here. Period of a simple pendulum, period of a simple pendulum doesn't depend upon amplitude of oscillation, provided that is most important condition, provided that amplitude should be small. Provided that amplitude should be small. To obey this law, amplitude should be small, less than 10 degree, or amplitude should be 20 times less than that of length of the pendulum. Then and then only this law is possible, otherwise not. Law of isochronous. So these are the 4 laws. Consult with period of a simple pendulum, or we can say that laws of simple pendulum. In this way, we have learned all the answers of all these questions that I have already written on RHS. So read the question carefully, listen my lecture carefully again and again, and write down the answers of each question separately. That will make you confidence regarding period of a simple pendulum. Okay, by taking next article, we will meet in the next lecture. Goodbye.